In this video, we are going to take a look at a few more examples of finding the arc length of the functions. So recall the arc length is just the distance traveled between 2 points on the curve where you follow the path of the curve. Now let's take a quick look at this example. We have y equal ln of the secant of x, and you are looking to find the arc length between the point 0 and pi over 3. So if you recall from the lecture, we have the formula to find the arc length. So if the derivative is continuous on 2 points A and B, then we can find the arc length by this formula, L equal the integral from A to B. And then we take the square root x prime square plus y prime square, and then dt. Or we can have a special versions. L, the length, can be the integral from A to B, and 1 plus y prime square dx, and y is just the functions f of x between the point A and B. And you can also have another special versions from A to B, and then we take the square root of x prime square plus 1, and then this is dy, where x is a function of y and y is running from 0 to b. So these two are the special version of the general formula. Alright, so this is a quick review. Now let's go over this example. So in this example, you are given the functions in terms of x. So this is y. So first thing is I need to find y prime. So I need to find y prime. Y prime, which is the derivative of y. The derivative of the ln function is 1 over the argument of the ln. And then we multiply to the derivative of the inside function by the chain rule. And I know that the derivative of secant is secant tangent. So on the top, we have secant tangent, and then at the bottom we already have secant, and now you can cancel the secant and you just get tangent of x for the derivative of y. And we just use the formula we have here on the right side, the special formula. So I have L equal A to B. A in this case is 0, and then B in this case is pi over 3. And I have the square root of 1 plus y prime tangent square, 1 plus tangent square of x, and then dx. And I simplify this integral. I know that 1 plus tangent square is secant square. So I have secant square inside the square root. And now we keep simplifying these expressions. We will have the square root of secant square. It's just secant, right? The square root and the power of 2, they cancel out. So secant of x dx, and the integral of secant of x is just the ln of the absolute value of secant of x plus tangent of x. And now you want to evaluate the answer from 0 to pi over 3 from A to B. And the last thing is we just make the substitutions inside the x. So we have ln secant of pi over 3 plus tangent pi over 3, and then we plug in 0, secant of 0 plus tangent of 0. And now the last step is to simplify everything. So we have ln secant of pi over 3 is 2, and tangent of pi over 3 is the square root of 3. And the next one, I have secant of 0 is 1, right? Secant is 1 over cosine. Cosine of 0 is 1, so 1 over 1 is 1. And then tangent of 0 is just 0. And because this one is a positive number, so you can take away the absolute value. So this is ln of 2 plus the square root of 3, and this is ln of 1, which is 0. So the final answer is just ln of 2 plus the square root of 3. For the second example, you are given the two equations, x in terms of t and y in terms of t's. And t is running from 0 to 1. This is a parametric equations. We are given x and y, and therefore you should use the first version of the arc length that we saw earlier. So L should be the integral from a to b, and we have the square root of x prime, the derivative of x square, plus the derivative of y square, and then dt. So now we have to find each derivative here. So in this case, I have x equal 1 plus 3t squared. So when I find the derivative of x with respect to t, I bring down the power 2, I have 6t. And similarly, I find y prime, I bring down 3, I have 12t squared. And now I'm ready to plug in everything to the arc length formula, the first version. So I have the t going from 0 to 1, and I have the square root, and then x prime, which is 6t square, plus y prime 12t square, and then square outside, and dt. And we can simplify this one into the square root of 6 square is 36t square, and 12 square is 144, and then t square t to the 4th power. Okay. Now in this case, we can also try to simplify the stuff under the radical. So let's go over here. I have 36t square, and I know that I can factor out 36t square, right? And if I factor this out, 36t square, I have 1, and 144 divided by 36 give me 4. When I pull out t square, I have t square left here. And now I'm ready to simplify this integral 0 to 1, and I have 36t square 1 plus 4t square, and then dt. And we know that the square root of 36 will give me 6. The t square, when you take the square root, you get t, right? And t is going from 0 to 1, so when you take it outside, you don't have to put the absolute value because this is already positive. And now inside the square root, we still have 1 plus 4t square dt, and we go from 0 up to 1. Okay, from here we can use substitutions to help you to find the integral. So if I let u to be the radicand inside here, 1 plus 4t square, then I find du, bring down to at dt, right? And therefore I can rewrite the integral. I have t and dt already. I'm missing number 8, so I'm going to multiply number 8 inside together with a t, and then also divide by 8. And then number 6, I just bring it outside, and I have the square root of 1 plus 4t squared dt. And now you see that at and dt give me du. And then the square root of the whole thing here now is u. And don't forget to change the limit of the iterations. So we have x, we have t. So originally we have t going from 0 to 1. 0 to 1. Now we have u. U is 1 plus 4t squared. When t is 0, u is equal to 1. And when t is 1, 1 squared is 1, 1 times 4 is 4, 4 plus 1 is 5, u is 5. Because you are taking the integral with respect to u. So now you need to change the limit of the integration 0 to 1 to 1 and 5. So 1 and 5 here. And finally, we can apply the power rule and then find the limit, find the integral. This is the power of up to 1/2 for the square root. So I just have to take 1/2, add 1, and then divide by that. Alright, and then we evaluate the limit from 1 to 5, and that would give me, if you simplify this one, this is 3 over 4. This is 3 over 4, and 1/2 plus 1, that is 3/2. Alright, 3/2. And then divide by 3/2 is the same thing as multiply by 2 over 3. And evaluate the answer from 1 to 5. And I know that 3 and 3 here can cancel out. And then 2 and 4 can cancel out, give me 2 down here. So I have 1 over 2. And then u to the 3/2. And it's going from 1 to 5. And finally, I can plug in 5 to u. So 1/2. 5, 3/2, and then minus plug in 1 to u. So 1 to the 2 over 3. And this is a typo, it should be 3 over 2. So let me erase that. 3 over 2. And this is 1. And minus 1/2, so this whole thing here just 1, and then we can simplify everything here. So I have 1/2, and then 5 to the 3/2, and then minus 1/2. And let's just multiply everything here and subtract 1/2. So I have 1/2, and then multiply to 5 to the power of 3/2. 1/2, not 1/5. And then minus 1/2, which is 0.5. And the answer should be 5.09. 5.09.